Hello, hello. We had a little bit of difficulty there. Hello. So I've got one person here. So yes, this is the new stream. Yes, fantastic. I lost you all. I lost you all. Where did you go? I got frozen out. I don't want to be frozen out. Oh, Rexy's got a post-it on his nose. Hello. Well, we'll just see if anybody else is going to join us, and then we'll try and you have to tell me where we picked up, where we last were. So that's going to be a little bit tricky because I don't know who else is going to join us. So that's going to be very interesting because everybody's on the other stream thinking, what's going on? I've still just got, I've got another person. Hello, hi, here you come. Yay! Here you come. Thank you for not running away. Thank you for staying. Thank you for staying. Thank you for staying. I don't know what happened there. Oh, loads of you are here now. Well done, well done. Thank you so much for staying and coming back. I lost you. Yes. I'm still here, and we can still pick up. So thank you so much for coming back. Thank you so much. Thank you so much. Hi. Hi. So I'm just going to get this up on my other screen so I can still see you all as well when you disappear. So I think I lost you at multiples of 5. Is that right? Can you just tell me when I lost you? Was that right at multiples of 5? Yep. Okay. Do you know what? I carried on talking for quite a bit after that. So we are here now. Let's carry on. Enough. So I'm going to drop you down again, and hopefully when I drop you down, you are going to stay with me and you are not going to disappear. So I'm going to show you a number track, and I want you to tell me what the missing numbers are. Okay, now there are 1, 2, 3, 4, 5 missing numbers. If you can try and type them in before you enter the return key so I can see the missing numbers. I'm just going to drop you down. Stay with me. Don't go away. Stay. Okay, down you go. Down you go. There's the number track. Okay. There's the number track. Can you fill in the missing numbers for me, please? Can you fill in the missing numbers for me? Yeah. Can you fill in the missing for me? Yep. So let's have a look. What are we counting in here? What are we counting in here? What are the numbers? What are the numbers? What are we going up in? Well, there's only 2 numbers together, so we might need to look over here to see what the difference is. And when I look over there and I see what the difference is between those 2 numbers, I can see that it is 9. So then I think, well, okay, is this the 9 times table? Let me see if that works. 36, 45, 54, 63, 72, 81, 90, 99, 108, 217. So the missing numbers are, these are the missing numbers. So we've got the 9 times table here. We have got the 9 times table. Yeah, we have got the 9 times table. We have got the 9 times table. So if you manage to get those missing numbers and put them in like this, yeah, then you can give yourselves a big tick. If you manage to get those missing numbers and write them in, the 9 times table. There are only 2 concurrent numbers here side by side. So that's where you had to look to see what the difference was so that you can see what the pattern was. So let's have a look at our next number track. Let's have a look at the next pattern. What are the missing numbers in this number track? What are the missing numbers in this number track? What are the missing numbers? So look where you can see the pattern. Look where you can see the pattern. We have got a mistake there, which is not going to help us. Yeah. Look where you can see the pattern, and then you'll be able to find out where the pattern was a bit erroneous. Look where the pattern is going down. It's a descending pattern, but look with numbers that are side by side, and you can see what the difference is. You can see what the difference is. And work out the pattern. And work out the pattern. Okay, so we have got a difference, 98 and 91, the difference is 7. 91 and 84, the difference is 7. So we can put our missing numbers in, and these are our missing numbers. 77, 70, 63, 56, 49, 42, 35, 28, 21. Okay, so there are our missing numbers. If you can, you've got all of those missing numbers, 7 times table, absolutely. Did you get your missing numbers? Let's focus on the maths. Okay, interesting that you're watching everybody else, but let's watch the maths. And now let's make up for lost time. If you've got all of those numbers, give yourselves a big tick. Very nice ticks there. Excellent, excellent. Let's have a look at the next pattern. Let's take those off. Okay, let's see if you can see the next pattern. Let's pull that up a little bit. What pattern is going on here? What pattern is going on here? What pattern is going up here? Look, 2 numbers side by side. Look at what the difference is. Look at what the difference is. See if you can work out what the missing numbers are. What are the missing numbers? What are the missing numbers? Okay. Yeah, well done. Yes, 8's exactly right. You've worked out the difference. Now let's get those missing numbers in. Let's see your answers. Let's see your answers. Otherwise, I'm going to think that you don't really know your 8 times table. That's it. Try and put your numbers in all together before you hit the return key. So let's see your answers. Come on then. Don't ask other people for your answers. Let's see your answers. Oh, it's not 6's. It's not going up in 6's. Just look a bit more carefully. Well done. First person to put all the missing digits in. Fantastic. Excellent. Excellent. Excellent, excellent, excellent. So if you put these missing numbers in, okay, so 32, 40, 48, 56, 64, 72, 80, 88, 96, 104, 112, 120. Yeah, brilliant. Well done. If you got those, you can give yourselves a tick. You can give yourselves a tick. Right, let's try another number track. Let's try another number track. We need to make sure we do not get slack on these numbers and that we stay sharp. That we stay sharp like a Sharpie. Let's just stay nice and sharp on our thinking. What is the pattern? Okay, have a look at the numbers that you can see sort of together. What is the pattern? What is the pattern? What is the pattern? What can you see? Four missing numbers. What are those missing numbers? Now, it's not 12s. Well, Sharpies, like a Sharpie, they do write with a nice sharp point. I didn't mean that they were sharp like a, you know, a point, but they, like a compass, but they do write with a nice sharp point. But let's focus on the maths more than what a Sharpie feels like. Otherwise, I'm going to think you're using avoidance because you're not sure. Okay, let's focus on the maths. Focus on the maths. Well done. Well done. Excellent. So the pattern is going in 6's. Well done. For those of you who saw that. Let's get those missing numbers in. Yeah, 6's is the missing difference. That is the pattern. Now let's get those 4 missing numbers. Let's just see those 4 missing numbers. Try and get them all before you hit the return key so I can see. I'm going to give you the answers. They go up in 6's. Okay, let's have a little look. The missing numbers are 48, 60, 84, and 96. Well done. Well done. Somebody just got the 96 in there at the end. Excellent. Excellent, excellent, excellent. Yep. Okay. So let's just do one to finish off, bit more tricky at the end. Let's just do this last one to finish off on number tracks. Then we're going to do something different. What is the pattern? 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 Can you put it in? What is it jumping in? It's a descending pattern, so it's going down. It's going down in tens. That's right. Got some answers coming in. Well done, well done. Well done, well done. Let's have a little look. Yeah, so if you're going to put comments in about other things than maths, you're just going to get a little bit frustrated. We will delete the comments so that the people who want to focus on their maths can. So let's have it. Oh, well done. That's okay. Great. I love it when I see people realizing they've made a mistake and then they really see it carefully. That's it. It's going down in the 10 times table. Well done, chickadees. I am so proud of you. I am so, so proud of you. So let's take those number tracks away. And now I'm going to give you something else to think about. So when we are doing multiplication and when we are doing division, we need to think about what factors are. What factors are of the numbers. So the number 60. Okay, what can you make equal groups of with 60? What facts can you make from 60? Here are some numbers. Which of these are factors of 60? And are there some factors of 60 which should be there but are not? Are there some factors of 60 that should be there but they are not? So have a little look. Okay, which of those are factors of 60? Absolutely 1 and 60. Let's get that out of the way straight away. 1 and 60. Let's get that out of the way straight away. So 60, factors of 60. Well, we can make facts of 1 and 60. We absolutely know that. And actually, 1 is not there. 60 is. So, yep. And we know that 1 is not there. So we can put that over there. 2 and 30. Love the way people are thinking systematically. Okay, let's see. Let's have a look. Maybe the next thing to look at is 3. Does 3 go into 60? Is 3 a factor of 60? You are shining. You're quite right. You shine, but put an E on the end of that shine. Otherwise, it's shin. Okay. 3 and what? 3 watts are 60. 3 and 20 are 60. Let's have a little look. So did we have a 3 in there? Okay, 4 and 15. 2 other sets, 4 and 15. Well done. I'm writing them up on the big boards. We got that one. We got that one. Yeah. Let's have a look. What else have we got? We've got 3, 20. We've got 3 and 20. Oh, we missed out. That's it. We've got 4 and somebody went to the 5. Yep, 5 and 12 are factors. Okay, 5. We've got 5 there. We've got 60. We've seen that one. And we can do the 6 one. Does 6 have a pair to go with? Does 6 go into 60? Well done. People are saying, yeah, 3 is not shown. Exactly. 6 and 10. Thank you very much. 6 and 10 are factor pairs. Yep. 6 tens are 60. Okay. Anything else? Anything else? The 7 go in there. 8, 9, 10. Oh, we've done 10, haven't we? We've done 10 with 6. 11, 12, 12 we did with 5, 13, no, 14, and 15 we did with 4. So let's have a little look up. So I wrote them on the board as all you clever chickadoos were telling me what was going on. I wrote them on the board. There we are. Can you see them? All the factors of 60. And I loved the way that you worked really systematically. 2s, 3s going up. Let's go up. So let's have a little bit of a brain teaser. So Grace has multiplied a whole number by 10. Now the answer that she got was between 440 and 540. So what could her original calculation be? What could it have been? If Grace multiplied a whole number by 10, if Grace multiplied a whole number by 10, and her answer was between 440 and 540, what could her calculation have been? So it's between, so it doesn't include 540, doesn't include 440. So what could her original calculation have been? What could her original calculation be? What could her original calculation be? Let's have a look. What could it be? What could her original calculation be? If Grace, okay, 54. So remember, we're not having 540, it's between them. So it could be not 54, it could have been the number one lower. So 10 times 45 is 450. Absolutely right. It could have been 45. It could have been 50 because 10 times 50 is 500. So you're quite right. 45, yeah. Could have been 50. Could have been 51. Could have been 49. Yeah. So that's got us thinking a little bit. Now, let's have a little think about using the maths we know already to help us to scale up. So let's have a look at our place value chart. Just going to make this a little bit smaller so it fits better on the screen. And let's have a look at our rules for multiplying by 10 and 100. Okay, so hopefully it's back on now because I can see it's not glitching. So what are the rules when we multiply by 10? So if I have 3 in my ones column, if I have 3 in my ones column, and I am going to multiply each of those ones by 10, what's the rules? What will I end up with? Will I end up, so 3 multiplied by 10. So each of those ones is going to become 10 times bigger. What will I end up with? 3 multiplied by 10. Really, really easy question. No trickery. Just checking your understanding. Okay. Okay, let's have a look. See some maths answers. Let's see some maths answers. Okay. Okay, so can we just watch the chat? Can we keep the chat to the first before the lesson? Because I can't see the maths answers come in. Thank you very much. Thank you. That's brilliant. Oh, what lovely, lovely, lovely learners you are. Brilliant. Okay. So yeah, so if I multiply 3 by 10, I get 30. I cannot put the 30 in the ones column. I have to put the 30 in the tens column. Now, what happens if I multiply 3 by 100? What happens if I multiply 3 by 100? So each of those ones gets 100 times bigger. What do I get then? What do I get then? I multiply 3 by 100. Yeah. Then I am going to get 300 because each of those ones has got 100 times bigger. So then I have got 300. So let's just look at that written down. Let's just look at that written down. Let me come back up so I can see you all. And you can see me. Obviously, I can't see you really. I like to think that I can see you. So when I multiply 3 by 10, I end up getting 30. When I multiply 3 by 100, I end up getting 300. So tell me what the rules are then. What is happening? When I make something 10 times bigger, what happens? When I make something 100 times bigger, what happens? Tell me. Tell me what maths is going on there. Tell me what maths is going on there. Show me your understanding. When you multiply by 10, what happens? When I multiplied 3 by 10, I got 30. So I needed to show it as 30. So what happens? What happens? Show me. You add a 0 on the end because what? What have they done in terms of place value? What have they done? The ones, when I multiply by 10, have gone over to the tens column. So they have moved one place to the left. And then I put a placeholder in. When I multiply 100, they take 2 jumps. So I make them 100 times bigger. 10 to the power of 2. I make them 100 times bigger. When I multiply 1,000, I make them 1,000 times bigger. So they take 3 jumps over that. Let's do that. Let's see how clever you are. Let's see how focused you are. Let us scale up. Okay. So looking at these questions, can you tell me, okay, using the maths you know and scaling up, 63 times 10. 63 times 10. Let's scale it up. Let's use the maths we know. Let's scale it up. 63 times 10. Yeah, move the one jump to the left. That's right. 63 times 10. What have we got? Let's see those numbers coming in. Oh, well done. People have got that straight in. I am going to take one jump to the left. So I have now got 630. Brilliant. Let's move to the next one. 80 times 100. 80 times 100. So I've got 80 and I'm going to make it 100 times bigger. 80 times 100. 80 and I am going to make it 100 times bigger. 80 and I'm going to make it 100 times bigger. Well, 800 would be 10 times bigger. Exactly. So now I have got 8,000. Sorry if it's a bit wobbly, but I'm running upside down. Okay, so 7 times 1,000. Make 7 1,000 times bigger for me, please. Make 7 1,000 times bigger. Let's make 7 1,000 times bigger. It's going to take 3 jumps to the left. 3 jumps to the left. 7,000. 3 jumps to the left. That's the number of zeros I have to add on. I've made it 1,000 times bigger. Let's make 85 1,000 times bigger. I've got 85 and I'm going to have 85 times 1,000. Okay, 85 times 1,000. Numbers coming in, and I can see some of you are lagging, so I've got your answers from the previous one. So well done, give yourselves a tick. Okay, so that's going to give us 85. Remember, I'm writing upside down, so I'm sorry if my writing doesn't come through as clearly as it could. 85,000. Okay, so you've got these. Give yourselves a tick. Give yourselves a tick. Okay. Well done. Good math thinking. Fantastic. Okay, fantastic. Well done. Okay. And number 5, 750 times 1,000. Let's have a little foot. 750 is going to take 3 jumps to the left. So what will we have then? 750. Oh, nice ticks. Well done. Well done, well done, well done. It takes 3 jumps to the left. Oh, answers coming in. Brilliant, brilliant, brilliant. Answers coming in. We are then going to have 750,000. Of course, 750,000. So, with that in mind, let us use the maths we have to solve these. Okay, let us use the maths we have to solve these. I want you, oh, so many post-its. I want you to, let's see how many we can get done today. Let's see. Equals, greater than, less than, equals, greater than, less than. What do we need to use? What do we need to use? Let's just do one at a time. This first one, is 300 times 120 bigger, equals, or less than 30 times 1,200? What is it? Okay. What sign will we need to put in here? What sign will we need to put in here? Greater than, equals, or less than? Greater than, equals, or less than? Oh, well done. Well done, those people who realized that actually they are equal. So this is an equal sign because they both come to the same number. They both come to 36,000. Let's have a look at the next one. 40 times 800, 8,000 times 4. What have we got here? Greater than, equals than, less than. Well done, those of you got it right. Excellent, 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 excellent. Okay, greater than, equals than, less than. Okay. Well done, those people who are really focused on the maths. That's what we're here for. Brilliant. Yep. And this one also is equals. This one also is equals. You see the same number of zeros. Okay. Let's have a look at the next one. 700 times 400, 70,000 times 40. 70,000 times 40. What are we doing there? Miss can't see. Why can't you see? Have I gone too far up there? Let me move it down. Okay, can you see now? Yeah. Is that better? Yeah. Well, this one comes to 280,000, and this one comes to 2,800,000. So we've got to use the less than sign because the bigger number is on that side. Okay, is on that side. Okay, so we'll finish the other greater than less than when we come back on Thursday. Let's just give you another little problem to think about. Just check you can see this. You're going to have to think the maths in this is not that hard, but you just need to think logically and use your systematic thinking. So Jordan's age is a multiple of 7 and is 3 less than a multiple of 8. He is younger than 40. How old is Jordan? Jordan's age is a multiple of 7 and is 3 less than a multiple of 8. Oh, well done. 2 people have got that answer in straight away. Well done. Well, I did it like this. I don't know whether you can see my numbers, but I just did the 7 times table and the 8 times table. And then I looked. I'm going to write it in darker pen so that you can see. I did my 7 times table. And I stopped because I knew he was less than 40 years old. And then I did my 8 times table. And then I stopped. And then I looked at those numbers, because there's my 7s, there's my 8s, to see where there was a difference of 3. And that is where there is a difference of 3. So just like some very clever chickadoos, is 20. Who got that? Who had your thinking caps on? And you got the answer 21, because that's how old Jordan is in this problem. So I know today the technology let us down a little bit and we had to go away and come back, and thank you. If you want to have a little chat without revealing any of your own details, remember to keep you safe. You can join the lesson early and have a chat then. But when we start, I really need your help to keep the maths focused on maths, because otherwise I can't really see who's struggling, and you know, sometimes you want to make it harder, sometimes you want me to make it easier or go things over. again, and I just need to be able to see those comments. It'd be really, really helpful to me if you can do that. That's absolutely amazing. Once again, I have loved spending time with you. Let us know about the afternoon or the morning, about the timing. I do think more people come on the internet in the afternoon, so that might have been why we had a few little technological hiccups there. But thank you so much for staying with us. I will see you on Thursday. We are back in the morning Thursday, so just watch for the times. And it has been lovely to see you again, lovely to be with you again. I know I can't really see you, but like it feels like I am. And to spend that time with you. So from Rexy and I, oh, we haven't done our flashing lights this week. Let's get our flashing lights. Let's get our flashing lights to say, well done. Have we got that the right way round? No, we haven't, but now we have. Okay, well done, and thank you from Rexy and I. So thank you very much for joining us, and we will see you on Thursday. Stay safe, stay healthy, stay indoors. I know that can be hard sometimes, but stay safe, stay healthy, and we really look forward to seeing you on Thursday. Make sure your grown-ups share the links for the lessons with lots of people so they can join us as well. And remember, if you want to have a chat, join the lesson early, and then you can do that little bit of chat without revealing any of your personal details beforehand. But once the lesson starts, it's all about maths, okay? And we don't have to take any learners out because they're disrupting, but we will have to if you can't focus on the maths. So join us early, and then you can have a little bit of a chat about what else you like to do without giving details away. But when we start those lessons, let's stick to the maths and let's be brainy mathies together, okay? Been lovely spending